Yes, welcome. Today we're going to be looking at homologous series. We're going to be looking at what? Homologous series. Homologous series. I told us that there are numerous numbers of organic compounds. We have up to 3,000 organic compounds. You understand? So in chemistry, these organic compounds are divided into, they are classified into families, into groups that share similar physical and chemical properties. You understand? And these groups, you have group called alkanes, we have alkenes, we have alkynes, we have alkanols, we have alkanoic acid, we have aromatic hydrocarbons too. You understand? So we have different groups. In order for us to understand the behavior of these these organic compounds very well, we divided them into groups. And these groups are known as what? Homologous series. So what is homologous series? Homologous series is a family of organic compounds which follows a regular structural pattern in which each successive member differs in its molecular formula by a CS2 group. So when we look at a group like alkanes, when you look at a group like what? Alkanes. These are the different homologous series we have. We have alkanes, alkenes, alkynes, alkanols, carboxylic acids, and so on. You understand? So the first member of the alkane is known as methane. It's known as what? Methane. You just use METH. You understand? And end it with what? End it with the rest of the numbers. So the first member of this is what? Methane. Give me another marker. The first member is what? Methane. That's the first member. You understand? So you can see this name is coming here, is it not? Yes. So the second member is what? Ethane. You can see this same thing is also here. But methane is for what? One carbon atom. Is that clear? Yes. Ethane is for how many carbon atoms? 2. Propane is for how many? 3. Butane is for how many? 4. Pentane is for how many? 5. The same way, the first member of alkane is also what? It will be 1. The second member will be what? Ethene. What? Ethene. So you have this similar to this, only that this is what? 2. Is it not? The third member will be what? Propene. Whereas here, the third member here will be what? Propane. Can you see that? So, if you look at the structural formula of this, the difference between this one and this one will be just addition of this. Once you add this to this, you get this. You add another this to this, you get this. Is that clear? So that is how they are in their families. So I'm going to clean this up so that we have what we had before. You understand? So the first homologous series, the simplest homologous series is known as the what? Alkenes. And it has this what? Formula. Can you see the formula? So now, ethene, we have this. How did we come about ethene having this? If you have this formula and you say you're taking the first one, methane, methane is 1, so it will be C, N will be represent 1, H will still be H. You have what? 2 times 1, is it not? Plus what? 2. So what will you get? You will get C, 2 times 1 is what? Plus 2, 4. CH what? 4. So this one will be what? Methane. Can you see that? Methane. How do we get ethane to be this? The same thing. C, instead of 1, what will ethane be? 2. H, in bracket, you have 2 times what? 2. Plus what? 2. So we will now have the formula to be what? C2. 2 times 2. 4 plus 2. 6. H, 6. Can you see it's C2H6? That's why we have ethane to be this. Is that clear? So we actually use the what? Formula. We actually use the what? Formula. And this is the formula that we are using. We are just replacing, for methane, we put 1 in place of N. For ethane, we put 2 in place of N. For propane, we put what? 3. So if you look at this methane, this is the formula. Who can tell me the difference between this and this ethane? Is it not just the addition of this? Because when you carry this 1C and add to this one, you have C2, is it not? When you carry 2H and add to this 4H, you have what? H6. You understand? So if you add another one here, another of these to here, like now you will now have C3 H what 8, and that will be what? That will be what? Propane, the third one. If you want to add butane, just add another of these to this. Is that clear? Is that clear? So we simply get subsequent one by just the addition of what? By the addition of what? CH2 what? Group. The same thing happens to this one. If you also add this one to this, if you put one here, you add to this, you get ethane, add another one, you get propane, add another one, you get what? Butane. You understand? So the most important thing is that you take note of the what? Formulas. You take note of the what? Of the different homologous what? Series. So you have alkenes, you have alkynes, you have alkanols. Example of alkanol is what? Ethanol. Example of alkyne is what? Ethyne. Example of alkene is what? Ethene. Example of carboxylic or alkanoic acid. You can also call this either carboxylic acid or you call it what? Alkanoic acid. Example of alkanoic acid is what? Ethanoic acid. And these are their formulas. All these their formulas are derived from here. Only that if it is ethene, if it is it that is starting it, you know that you are replacing N with what? 2. If it is prop that you want to start, you will replace what? N with what? 3. Then you derive the formulas. All these their individual formulas are derived from these general formulas. Is that clear? But note what you want to start with. If it is meth, it's 1, eth 2, prop 3, but 4, pent 5, hex what? 6. So that's how you come about the formulas. Knowing these very formulas, very, very important. The individual formulas of the homologous series. So the different homologous series that we have are what? Are